Hello team and family, this is video number 2 for using ratios and rates to solve problems. In the science club, there are 2 6th graders for every 3 7th graders. At this year's science fair, there were 7 projects by 6th graders for every 12 projects by 7th graders. Is the ratio of 6th graders to 7th graders in the science club equivalent to the ratio of science fair projects by the 6th graders to projects by the 7th graders? Explain. So, I'm going to do two things. I'm going to compare the 6th graders. So let me put my what here. That's going to be in the table. I'm comparing, write it in yellow. What? I'm comparing 6th graders to 7th graders. And the other thing I'm comparing is projects, so 6 projects to the 7th projects, or 7th grade projects. So first I'm going to do the ratio for 6th graders to 7th graders. So there's 2 6th graders for every 3 7th graders. So then if I multiply 2 times 2, that would give me 4, and 3 times 2 would get me 6. If I multiply 2 times 3, that would get me 6, and 3 times 3 would get me 9. If I multiply 2 times 4, it would get me 8, and 3 times 4 would get me 12. I'm going to stop there, and I'm now going to do the table for projects to 7th grade projects, so 6 to 7th. There were 7 projects by 6th graders for every 12 projects by 7th graders. So if I do maybe the first 3, 7 twelfths, 7 times 2 is 14, 12 times 2 is 24, 7 times 3 is 21, 12 times 3 is 36. So when I look at these numbers and I see if they're equivalent, I see a 12 in the denominator spot and a 12 in the denominator spot, but I see two different ratios. I see 8 to 12 and I see 7 twelfths. 8 to 12ths, or 8 twelfths is greater than 7 twelfths, so it's not equivalent, and I can write down the two ratios are not equivalent, because when I look at the table, the bottom number is 12 for 7th grade, but for 6th graders there should be 8 6th graders, which means there should be 8 projects if they're equivalent, and there were only 7. So the two ratios are not equivalent.